Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 4 of the biostatistics, which is talking about the sets and probabilities. And in this video we are going to discuss the probability from the point of view of the sets, or probability from sets perspectives. Before starting with the probability, I would like just to review or to go through this slide, which we have it in Debrecen PDF file, which is linking between the sets and probability. So here it talks about the operation of set theory. The set theory can be applied to event. When we find the word events means probability. I have one event. I have withdrawn one ball from a bag, or have thrown the dice. So this is an event. Event always, when it comes in the biostatistics, means it has a probability problem. Okay, so we will discuss the events or the probability, but which is related to the sets. Okay, so here the first example which they have given here and talking about the universal sets. Universal sets means everything which I have, the domain which I'm working in, all the possible answers or solution, or all the possible elements. Okay, universal set correspond to certain event. What does it mean, certain? Certain event means I'm sure 100% it will happen. For example, I have a set A, which includes A, B, O. This set, as we can see here, it represents the blood groups. The human blood groups is blood group A, blood group B, blood group AB, or blood group O. This is set A. Okay, so if I have a domain or the universal set, which is U, okay, that includes the set A, B, AB, O. So, what is the possibility if I have taken randomly one of these a person, and I've made blood test for him? Okay, and of course, since this is the result of the blood test, A, B, or O, he would be one of them. So if I picked one randomly, it could be B, could be AB, could be A, could be O. What is the probability that the selected person will have a blood group which within the domain, within the universe? It is 100%, because the universe itself, including everything, including set A and any other things. In our case, blood group, we don't have any other groups. So the universe includes even anything. So if I withdraw B, the person who has blood group B, so it will be existing in the universal sets. If I withdraw AB, also it exists in the universal sets. If I withdraw A, also it does exist in the universal set, because universal set, it covers set A or any other set there. Okay, so it is certain that it will have no other person in the world will have any other blood group apart from these 4 groups. So if I'm taking my universal set, the full universal sets, so it should be 100%. Okay, the universal set covered everything within it, and set A, it is part of the universal. Okay, so anything within set A, it will be part of the universal set. Okay, so the possibility that if I withdraw something from set A, it will be part of the universal set, it is 100%. Because universal set is everything. For example, to make it more easier, you have a house, okay? And you have table, chairs, you have kitchen, you have a stove, you have fridge, you have everything, okay? What is the possibility if I withdraw a chair from your house itself? Is it possible that it will be part of your house? For sure it will be, because you have withdrawn it already from my house, from the universal set, which is my house in this case. And the chair is one element of my house. Maybe it is part of the kitchen set or part of the dressing room set. Every one of them has separate chairs. But at the end of the day, it is part of the universal set, part of the house. So the possibility will be 100%. So here, the possibility of the universal set correspond to certain event. Certain means I'm sure 100% it will happen. And as we know that the probability is more than or equal 0 and less than or equal 1. It cannot be less than 0 and it cannot be more than 1. If any problem you have answered or solved and find the answer of the probability is more than 1 or less than 0 negative, this means that you have something wrong in your calculation. You have to revisit it again. Okay? So this is the maximum which is corresponding to 100%. And 0 corresponding to 0%. Okay? So 1 is 100% and 0 is 0%. Okay? So certain event means 100%. 1 cannot be anything else. You are using the whole universe. Okay? If I'm talking about the earth, our universal set, for example, is the earth. And they said, okay, I have withdrawn a tree. What is the possibility it will be part of the earth? So far we don't know trees except in the earth. So the tree is part of the earth. So it's part of the universal set of the earth. So the possibility or the probability, it is 100%. Okay? Okay. Another example here, another operation. The empty cell, empty sets, we have a notation of phi, or open brackets, open parentheses. Okay? So this is the notation of the empty set. The empty set, it doesn't have any elements in it. Okay? It doesn't have any element in it. The empty set corresponds to impossible events. It is impossible. If I draw anything, okay, number, alphabetic letter, pen, pencil, photo, image, whatever, okay, what is the possibility it will be part of the empty cell, empty set? It is 0 because it is empty set. If I was draw something in a number, in a blood group, in a picture, anything, it cannot be part of the empty set because empty set is empty. It has nothing. Okay? So it is impossible event that I was draw something and it will be, and it is my hand and it will be part of the empty set because empty set has nothing inside it. And if I have something in my hand, it cannot be part of something which is empty. I cannot get something from an empty thing, right? I hope it's clear. So I have empty set, has nothing, and I withdraw something, sample, alphabetical letter, color, sweet, fridge, picture, photo, anything. It cannot be part of the empty set because empty set is empty. We cannot take anything from it. So it is impossible event. So the possibility or the probability is 0. So it's called impossible event. So now we knew that certain event, 100% it will happen if I have the universal set which includes everything I'm interested in, and I picked one of these interesting things which I'm interested in. It must be part of the universal set. But I'm picking it from the universal set itself. But the empty sets, if I was draw something from anywhere, and how much it is possible that it will be part of the empty set, it is 0. It cannot be anything, cannot be part of the empty set. Okay, this is the second point. So coming to the next one, which is union of sets. If I have a union of sets, two sets united together, joined together. So union of sets means all the element in set A and all the element in set B, all the element in set S and all the element in set T. Okay, so it is all the element, either it is in first set or the second set, all together. So for example, if I have set A and the probability of happening is 0.3, and I have set P and the probability of happening is 0.6, so the total probability of A or B, which is union A, union B, means in A or in B, the element is in A, set A, or in set B. So the probability, it will be either here it will be right or here it will be right. So it will be 0.3 plus 0.6. So, okay, so I said if the element which I have selected, what is the possibility it will be part of the set A? Okay, it is the probability is 0.3. So here, if the element which I have selected from group B, the possibility is 0.6. So if I said, just let me remove some of these lines. Okay, so if I said that the element that I have selected from B, the probability of it is 0.6. So what is the probability if I selected one item? It will be either in A or B. Any one of them is right, A or B. If it is A, it will be right, and B, it will be right. So what is the possibility? It will be 0.3 plus 0.6. So the union of sets correspond to the sum of the events. Okay? So here, the total, the sum of the events. So here the possibility it will be 0.3, and here it will be 0.6. So the possibility it will be either here or here. Any one of them is right. It will be the sum of them. This one plus this one. Okay? 0.3 and 0.6, 0.9. And I have another one which is set C, which is 0.1. So the total is 1. So always the total probability of the universe is 1, full 1. So I have 0.3 here, 0.6 here. So the rest or the remaining 0.1, it will be either in the universe itself or in group, in set, another set like set C. To make it clearer, I think it's better to have this example. Let us assume that we have P, which is 2, has element of 2, 3, 8, and 12. And also let's assume that we have the universe of 1, 2, 3, 7, 8, 10, 11, 12, 15, 16. This is the whole universe, the universal set. What I mean by universe here, the universe of this problem, okay? What's called the universal sets, or the domain, or the universal sets, okay? And also I have another group of, which is called Q. Q will consist of, let us say, 3, 7, 11, 12, 15, okay? Okay, so if we have this is P, and this is Q, and this is the universal sets. So let us get the Venn diagram of it and put it here. Just let us check whether it's drawn right or wrong. So here set P, 2, 8, 3, and 12, the 4 numbers, okay? Q, 3, okay, 7, 11, 12, and 15. So if I want to draw such type of universe, as you can see here, I have drawn the universe, and I draw set P and I put all the numbers. I draw set Q and put all the numbers. But before that, I have to check what is the common between them. What is the common between P and the Q, because I cannot put them and then repeat them. So before that, I have to find the intersection of the two sets. What is the intersection of these two sets? As we can see here, I have 3 is common in set P and also it is in set Q. I have 12 is common here and 12 also is common here. So nothing else. So I know that in the intersection of P and the Q, I'll have 3 and the 12. Okay? Okay. So I will draw my domain, my universal sets, U. I draw the two sets, P and Q again. So I'll get the two common items. I'll put them in the middle, 3 and 12. And the rest I'll put in P and in Q. So here If I remove 3 and 12, which I already put in P, so in P I'll have 2 and 8. In Q I'll have 7, 11, and 15. Okay, so I have already selected 2 taken, 3 taken, 8 taken, 12 taken, 3 already taken, 7, 11, 15. So I have 1 is not taken, so it will be outside here in the domain 1. What else I have? I have 10 and I have 16, so 10 and 16. This is the way I'm drawing this Venn diagram and the distribution of the sets. And I think all of us have gone through this during their secondary school studies. Okay. So let us now give an example to understand. I have now 10 elements inside the universal sets. Okay, 10 elements. If I pick one element, okay, from this universal sets, what is the probability that it will be part of P, of set P? So I have to check probability of being in set P equals how many elements inside set P? 1, 2, 3, 4. 4 divided the universal set, which is 10. So it is 0.4. So what is the probability it will be the number which I picked randomly part of Q? It will be 1, 2, 3, 4, 5. 5 divided 10 equals 0.5. Okay. So if I said probability of P united Q, this means that P united Q means that it could be in P or in Q, it will be right. If it is in P or Q, P united Q means any of them will be right. So here P united Q will give us what? Let us put it in a new line. So it would be, okay, P united Q equals a new set, which is P united Q will be 2, 3, 7, 8, 2, 3, 7, 8, 2, 3, 7, 8, 11, 12, 15. 11, 12, 15. So if I picked any number randomly, what is the possibility of being P united Q? Is it bigger or only P? P only has 4 elements, so it is less likely to happen. So if I pick a number randomly, it has 4 chances. Either it will be 2 or 3 or 8 or 12. 4 chances out of 10. But what is the chances it will be P united Q set? Will be element of P united Q. It will have how many chances? 1, 2, 3, 4, 5, 6, 7 chances. So I have here bigger chance. So probability of being element of P united Q, it should be bigger than P and should be bigger than Q. Okay? It should be bigger than any of them. Any of them. So it will be the probability of P plus the probability of Q, right? Yes, but something missing here. Probability of P, it could be full B. Probability of Q, it could be for Q. This means that I have considered this part twice, which is not right. I should not have this overlap because 3 and 12 are in P and 3 and 12 also are in Q. So the right or the general formula for the probability of P united Q, it is the probability of being part of element of P or the probability of being part of Q minus the probability of their intersection. Probability of P intersect Q. What is the probability here? 2, right? So here 0.4. plus the probability of Q 0.5, right? Minus the probability of P intersect Q, P intersect Q equals 3 and 12 only. So it is 2 divided 10, 0.2 minus 0.2. So it will be 0.4 plus 0.5, 0.2 plus 0.5 minus 0.2 equals 0.7. So this is the probability of P united Q. So the probability of something united other thing, it will be the probability of the first one plus the probability of the second one if they are disjoint. Probability of this P plus probability of Q. But if they are joint or not disjoint, you have overlap, so it will be probability of P plus probability of Q minus the probability of the overlap, which we have here, okay? I hope this one is clear also. So, the union of sets, as mentioned here, the union of sets correspond to the sum of the event. So if I want to get the probability of union of two events, it is the sum. It is probability of P united Q equals the probability of P plus probability of Q. But subject to P and Q are disjoint. This is P and this is Q. In this case, this is right. The probability of this one plus the probability of this one. Because it could happen here, if I book a big number randomly, it may be baked from here or from here. So it has a bigger chance. Okay? But if they are not disjoint, so they have overlap, they have intersection, this area. So this is P and this is Q. It will be the probability of P united Q equals probability of P also, probability of P plus probability of Q, but here we have to add minus probability of P intersect Q. P intersect Q, okay? This is the element. If there is no intersection, so the probability will be 0. So this will be eliminated. It will be ignored. So we'll come back to probability of P plus probability of Q. It is the same. Okay? I hope it is clear. If it's not clear, maybe I can repeat it again. Or I can give one more example to make it more clear. So to make it clear, because actually this statement here is not so clear, or it's not covering all the scenarios. So the union of set, if I have two sets which are union, for example, set A union set B. So set A union set B. The probability of set A happening called PA, probability A. Probability of set B called probability B. Probability of A united B means this or this. So A united B is a set which is bigger than A and bigger than B. A big boat which we can put a big basket which we can put a lot of stuff. We can put all the stuffs in A here and all the stuffs in B here, all the items or the element in A here and all the elements of B here also. Okay, so it will be a big boat, A united B. So the chance in the case of A united B is very big, on contrary to the probability of A intersect B. Okay, so just let us give an example. If I say 0.5 plus 0.2 equals 0.7, so the number increased. But if I said 0.5 times 0.2 equals 10, and decimal places after 2 points, so it will be 0.1. So 0.5 times 0.2, it is times. We're supposed to have times the numbers in times calculations. or multiplication, it should be increased. Yes, it should be. But in our case, it is decimal because the probability always are decimals. So if you multiply decimals or fractions, you will get a smaller number. So 0.5 times 0.2 will give you a small number, which is 0.1. So if it is less likely to happen, the chance is smaller, so it has to be multiplication. If the chance increased, so it has to be plus. This is in short, just to remember it. Okay, if you feel the chance is increasing, so it has to be plus this probability plus this probability. If the chance would be less, so we have to multiply the probability by the other probability. So in this case, if we are talking about A union B, do you think it is bigger the chance of happening that the item will be, the element which will be selected will be exist in A or B? A or B? A united B means any item here in A, or A items and B items is bigger, or the chance of A only? Of course, A united B, chance will be bigger, so here it will be plus. Okay, so again, coming back to the example which we have given here on the P and Q. Okay, if you remember in the example, we said that P is a set 2, 3, 8, 12, and the Q this set, and this is the universe. And then we get P intersect Q in 3 and 12, as we drawn here in this Venn diagram. You can see the intersection is 3 and 12 here. 3 and 12. Okay, this is P and the Q, 3 and 12. Okay, and P united Q is 2, 3, 7, 8, 11, 12, 15, which is combination of P and Q. It is bigger than any of them, bigger than P and bigger than Q. So if I said what is the chance if I pick a number from P, which is chance of picking a number from P, it's called probability P. Probability of P equals, I have 1, 2, 3, 4, 4 over 10, which is 0.4. Probability of Q equals 5 over 10. 1, 2, 3, 4, 5 over 10. Probability of P united Q together. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, here P united Q is here. Okay, 1, 2, 3, 4, 5, 6, 7. 7. And the total number of the universal set is 10. So equals 0.7. Okay. Probability of P intersect Q. Only the intersect 1, 2. 2 divided 10 equals 0.10. So I get all the probability. So if, like in this case, what is the probability of P united Q? Probability of P united Q. Someone will say, okay, we have already got it here. P united Q. We have wrote P and Q here. And we calculated, yes, but if we want to write as a formula, equals the sum of the probability of P plus the sum of the probability of Q, right? Right, but with something which we will mention now. So equals probability of P plus probability of Q. Because the probability will increase to have all the numbers in P and all the numbers in Q. So probability of P plus the probability of Q. But we have some overlap here. We have these numbers which is repeated here and there. Okay, so it will be probability of P, which is 0.4, plus probability of Q, which is 0.5, which is 0.9, but our answer here was 0.7. Yes, because we have overlap, which is counted twice. It was calculated with P and it was calculated also with Q. It was calculated with both of them, which is wrong. It has to be calculated once. Since we got all P and all Q, so it has been calculated twice. One time calculated with P and one time calculated with Q. So we have to delete one time of them, to remove one time, subtract one time. So minus the probability of P intersect Q. Okay? Which is P intersect Q, it was 0.2 minus 0.2, which equals 0.7. The same answer which we have got here. So we have two ways, either to solve it with the formula or to write the subset and count how many numbers. Okay, so this is the formula. It is the probability of P united Q equal probability of P plus probability of Q minus the intersection between them. The probability of the intersection between them. So what if these two sets are not intersecting? So I have two sets like this. There is no intersection here. There is no intersection. The two sets P and Q are separate. Here there is nothing here. No intersection. So what is the probability that any number will be in the intersection? There is no intersection at all. So the probability of the intersection is 0. Okay? So we can come here and put this probability of the intersection here as 0. So this one will be 0. If this one becomes 0, so the probability will be probability of P only plus the probability of Q, which we usually use the probability of P united Q equals probability of P plus probability of Q. Many people are just memorizing this formula and forget minus the intersection, because we have in many of the questions, we have disjoint sets. The sets are disjoint, they're not linked. So this formula is valid. But if there is a case where you have intersection like this one, you must subtract the intersection. If you don't have, put it 0, so you can only memorize one of them, this formula only, which is P united Q equal probability of the first one P plus the probability of the second one Q minus the probability of the intersection. And if the intersection is 0, there is no intersection, so put it 0, you will end up with probability of P plus probability of Q. So now we'll come to the next one, which is intersection of set. What is the probability of the intersection of the set? The probability, it will be the product. Product means multiplication. Multiplication. Always when you find the product means multiplication of the probability of the events. So let us take this intersection which we have here. What is the probability of, or this one, the probability here? P, let us erase this one. The probability of P intersect Q. Probability of P intersect Q. P intersect Q, P intersect Q, how many elements we have here? In P, we have 4, 1, 2, 3, 4. In Q, we have 5, 1, 2, 3, 4, 5. Intersection is smaller than, because not all P are inside Q or not all Q are inside P. So in the intersection, we have lesser number. Only 2 elements are common, and they are intersecting each other only in 2. So P, the probability of P, it will be 4 divided 10. Probability of Q, it will be 5 divided 10. But probability of P intersect Q, it will be only 2 divided 10, because you have only 2 elements, 2 divided 10. So it becomes smaller. It is less chance that the number will be only 3 or 12. If I said the chance will be 2 or 8 or 3 or 12 or 7 or 11 or 15, it is a bigger chance. But if said a bigger number, what is the chance? It will be only 3 or 12. It will be a lesser chance. This means it is multiplication. So the probability of P intersect Q equals probability of P times probability of Q. The probability of P equals big probability, 0.4. Probability of Q is much bigger, 0.5. So If we multiply two decimals or two fractions, it will be smaller number. So it will be 4 times 5 equals 12, and the decimal after 2 points, so it will be 0.2. So the probability of P intersect Q, it is less chance because only two numbers, not 4 like here or 5 like here. It is only two numbers, so it will be less chance. So intersect, it will be the multiplication, the product of the event, the product. In the case of the union, if you remember, we made it plus. So probability of P plus probability of Q minus the intersection, okay? So coming to the probability of complementary set. Complementary sets means that I have one set, for example, set A, and its probability is 0.4. So complementary means anything which doesn't belong to this one. So all the universe except this one. If I remove this one, it will be everything else. So I can say here, sorry. I can say I'll put my thumb here, I'll hide this one, and anything else outside this A, anything else, it will be the complementary. So the probability of the complementary, the total probability of anything is 1. The 100% is 1. So if this one 0.4, so what about the probability of the complementary? 0.6. So it will be 1 minus 0.4 equals 0.6. So the probability of A plus the complementary of A, which we said that we write it as what? A dash. If you recall, we said that we write as A dash. Okay, so the probability of A plus A dash, this A plus A dash, the outsider, anything else, equals 1. Anything plus its complementary is 100%. Because when you say the complementary, so anything in the reverse except this one. So we said A and the complementary of A. So we put our finger, our thumb on hide A, and anything else, it is complementary. So both of them together, they will form 100% the universe. And the probability of the universe, we said it is certain, it is 1. Okay? So the probability of anything and its complementary is 1. So the probability of the probability of A complementary equals 1 minus probability of A. That's it. So if we said the probability of A is 0.4, so probability of A dash or A complementary equals 0.6, 1 minus. Okay? If probability of A is 0.3, this one will be 0.7, and so on. Okay? Okay, so the complementary set correspond to complementary event. The probability of complementary also in the events or in the probability means 1 minus. Okay, so this is what you call joint and disjoint. So here we have mutually exclusive events can be represented by disjoint sets with no intersection. So this is called mutually exclusive. Exclusive means independent. No one has the relation to the other. Everyone is at its own. This is called mutually exclusive. This one mutually exclusive from this one. Exclusive. There's no intersection. Okay? And in this case, it will be the probability of A, okay, union, which is called union, called OR, A or B, which will make the elements bigger in numbers. If I have five numbers here, 5 elements and 4 elements, so when I said this one united this one or union this one, it will give me 9. Okay, so A union B will be equals to the probability of A plus the probability, because here they are disjointing, they are exclusive disjointing, mutually disjointing, this mutually exclusive event represent disjoint. But this one is non-mutually exclusive. It is not disjoint, they are jointing, they are not disjoint, not non-mutually exclusive. This means that mutually exclusive is separated. Mutually exclusive, and what means what? Separated. Okay, I hope that this slide also is clear.